Alright guys, just a couple application problems in section 3.4. A few things to notice in this word problem. Y is in thousands of dollars. So when they say 50,000, you leave it as 50. You do not write out 50,000. So we are going to type in 50 equals need my calculator for this problem. Alright, so it is asking us during which year. So we are solving for t. Notice this whole thing here is all one term, so be careful. Your first step is going to be to subtract 33.374 from 50. So go ahead and solve this equation for t. Notice when you come to this part right here, in order to get rid of ln, you need to change that, convert it to exponential form. Ln means log base e, so t equals e raised to this decimal. So t is approximately 6.13. Going up to the problem, when they say t represents, when t equals 4, it represents 2004. So that means when t equals 6, that would mean it is happening in the year 2006. So our answer is 2006. Go ahead and solve this problem for which year public school teacher salary would reach $52.5 thousand. How would that change? So find the year. This answer would be t equals 8.06, so this would be the year 2008. Alright, next example problem. On the PSATs this year, you guys asked me about that lovely phrase, the constant k. So for part A here, find the value of k for the model. So looking here, they're giving us an example. Once again, they're telling us a specific example of what t equaling 6 is. So 2006, just like the previous problem. T is representing the number of years after the year 2000. So they're giving us a specific example. In 2008, the population was 7,000. So that means 7,000 is going here. And t isn't 2008. T is going to be 8. We are solving for k. K is constant. Our input variable is t. T is the one that's changing. T is the years. So solve this equation for k. Alright, notice that in order to get rid of base e, I had to take the ln. And also I rewrote k8 as 8k. And the question said to round to the 4th decimal place. Alright, part B. Now use your model. Your model has this new k in it. Use your model to predict the population in 2018. Your new equation here has the constant k plugged in, and now you are solving this for the year 2018. Alright, so this equation here, population in thousands, t equals 6 is corresponding to 2006. That is similar to the previous example we just did. They are giving us an example. You guys talked to me after the PSAT talking about the constant k. What was that talking about? So that is something you are solving for, and once you solve for it, that is constant in your equation. Your input variable is t. That is the independent variable that can change. So when they give you this example here, 2008, so that is the year when t equals 8. So we're plugging in 8 for t. And our population is 7,000. Be careful. P is in thousands, so you're plugging in 7 for P. Here is your equation. Solve for k. I show my steps here. Please take a look at the right. I would not necessarily, in my notes, put all of this down. I just did that for you guys. I do not round. Notice on the calculator, I just use the previous answers. You can always use the up arrow to highlight and hit enter to copy a previous answer, even if you are in the middle of typing out operations. Your answer here, the question said to round to the 4th decimal place. So that is your constant. So that constant will be used in your equation over here. Part B asks for you to predict the population in the year 2018. So go ahead and solve that for 2018 using your new constant k, and now you are using 2018 for your input t. Be careful. T is 18 because remember 6 is corresponding to 2006. Our answer is 9.676, but P is in thousands, so the population, the prediction for the population will be 9,676 people. I hope this cleared up some examples for solving exponential and logarithmic equations. Thanks, guys.